Okay, let's dive right into this explainer. If you've ever tried to picture life in prehistoric times, you've probably imagined a pretty brutal, incredibly brief existence, right? The popular narrative out there tells us that our ancient ancestors were incredibly lucky to even see their 30th birthdays. We kind of just picture them dropping dead of old age right around the time modern humans are, just settling into their careers. But is that actually true? Were human bodies biologically programmed to expire so early, or is there a massive misunderstanding in how we read the data? Let's unravel this central mystery of why we think ancient humans died so young and figure out what was really happening in the prehistoric world.
So a super fascinating discussion on a popular Ask Science forum actually kicked off this whole investigation with a brilliantly straightforward question. In caveman times, what would most humans have actually died from? Starvation, disease, old age, or, as a few hilarious commenters suggested, battles with velociraptors. Now, setting aside the tiny little fact that humans and dinosaurs missed each other by about 65 million years, the genuine answers to this question reveal a prehistoric mortality landscape that is incredibly complex. The truth is, our ancestors absolutely weren't just helplessly waiting around to die of old age in their 20s.
To really understand this myth, we have to look at how we actually measure human lifespans. The famous 30-year lifespan you always hear about, it's a statistical quirk. It's based on something called life expectancy at birth, or LEB. This is not some biological expiration date that was hardwired into them. It's literally just a statistical average. And in a population with incredibly high infant mortality, that average gets dragged violently downward. So if a society has a life expectancy of 30, it doesn't mean you have a bunch of people keeling over from old age at exactly 30. In reality, it means a huge chunk of the population will die before the age of 5, while the rest might live well past 50.
Which brings us to this massive revelation. If a prehistoric individual managed to somehow survive those incredibly dangerous early years of childhood and reach age 15, their life expectancy completely transformed. The data shows that the Paleolithic life expectancy at birth was roughly between 22 and 33 years. But if that exact same person reached age 15, they could expect to live an additional 39 years on average. That means the surviving hunter-gatherers were regularly living to be around 54 years old, with a significant number of them reaching well into their 70s.
So what on earth was causing this massive statistical skew? If it wasn't old age, why did most die young? What was wiping out the very young at such a high rate? The answer is staggering. In the Paleolithic era, an estimated 75% of deaths were caused by infections. This created a brutal, high-intensity childhood mortality filter. You see, before the advent of modern medicine and antibiotics, the human immune system was fighting a constant, desperate war against environmental pathogens. If you couldn't survive this early onslaught, you just never made it to adulthood, which mathematically anchors that average life expectancy so incredibly low.
Let's break down exactly what these real prehistoric killers were. For infants, the absolute biggest threat was diarrheal illnesses, which lead to rapid dehydration and starvation. For adults, minor wound infections from soil pathogens were incredibly lethal. A simple scratch could literally kill you. We also have to factor in the cumulative risk of childbirth. While the natural death rate was about 1% per birth, having multiple children compounded that risk significantly over a lifetime. And finally, for highly active hunter-gatherers, accidents, trauma, and broken bones were constant threats that could easily lead to fatal secondary infections. But here is where it gets absolutely fascinating. Let's contrast those ancient killers with the things that take us out today. Modern humans are mostly plagued by chronic diseases of civilization, things like heart disease, cancer, and complications from obesity. But in pre-agrarian hunter-gatherer cultures, these diseases were almost entirely non-existent. Our ancestors were remarkably fit. They had these high-fiber, nutrient-dense diets. They completely lacked exposure to modern chemical toxins, and they lived highly active lifestyles. If they avoided a fatal infection or a bad fall, their bodies functioned with an incredible natural resilience right into old age.
Section 1. The agricultural disease boom, when farming made us sicker. Let's move to this and see how the invention of agriculture completely changed our biological landscape. For hundreds of thousands of years, we were these highly mobile foragers. But around 10,000 to 12,000 years ago, we underwent the Neolithic Revolution. We invented agriculture and stopped our constant movement. And while this obviously allowed us to build civilizations, it also kicked off a massive boom in infectious diseases. This health decline basically happened in 3 distinct steps. First, we settled down, which dramatically increased population density. Humans lived shoulder to shoulder, allowing diseases to just spread like wildfire. Second, we introduced animal husbandry. Living so closely with domesticated livestock allowed zoonotic diseases to jump the species barrier right into humans. And third,
Poor sanitation. These dense new settlements had no real sanitation systems, meaning massive concentrations of waste became perfect breeding grounds for harmful bacterial infections.
This whole process resulted in a really profound timeline of pathogen evolution alongside human society. In the Paleolithic era, our immune profiles and ancient DNA tell us the landscape was mostly characterized by viral infections and soil bacteria. But as we transition into the Neolithic, we see a sharp rise in bacterial and zoonotic infections directly tied to our livestock. Then, by the time we reached the Bronze Age, populations had grown so incredibly dense and trade networks had become so expansive that the stage was perfectly set for something truly terrifying: large-scale, continent-spanning epidemics.
Now, what's really interesting about this slide is the physical evidence researchers have mapped out here. Through ancient DNA screening, they've actually found traces of Yersinia pestis, which is the bacteria responsible for the plague, in human remains dating back roughly 5,500 years. Amazingly, they also found it in a late Neolithic dog in present-day Sweden, and this perfectly aligns with human infections found in northwestern Europe at the exact same time. This literally proves that humans and their domestic animals were already sharing some of history's deadliest pathogens millennia ago. But before you picture a prehistoric Black Death wiping everyone out, there is a catch. This early version of the plague bacteria was missing an absolutely crucial piece of genetic code called the YMT gene. Without this specific gene, the bacteria couldn't survive in the gut of a flea, which means it couldn't be transmitted rapidly through flea bites. So while early farmers and their dogs were absolutely catching the plague, it resulted in isolated, localized outbreaks, rather than the massive, civilization-crushing plagues that would emerge thousands of years later.
Section 2. Prehistoric Healthcare. We were never helpless. Now, with all this talk of relentless disease and brutal childhood mortality, it's super easy to just view our ancestors as helpless victims of their harsh environment, but they actively fought back against these biological threats. Internally, our bodies adapted through what evolutionary medicine calls the thrifty genotype. To survive the Paleolithic environment, humans evolved a heavy bias toward a hyperreactive, robust inflammatory immune response. Think about it. In an era where a minor scrape could introduce fatal soil bacteria, a massive inflammatory response was literally a life-saving superpower. On top of that, our genes adapted to efficiently store fat and retain salt to survive periods of sudden famine and dehydration. Ironically, today these exact same genetic traits contribute to modern autoimmune diseases and obesity. But back then, they were the ultimate survival tools.
Externally, our ancestors were brilliant observers of the natural world. They basically invented ancient pharmacology. We actually have hard evidence from dental calculus and preserved remains that early humans knew exactly what they were doing. They used willow, which actually contains the active ingredient in aspirin, as an analgesic for pain relief. They utilized honey as a natural antiseptic to clean out wounds, and they chewed on specific fungi and birch tar, which contain natural antibiotic properties, to fight off bacterial infections. They literally had a functional, working pharmacy right there in the forest.
But honestly, perhaps their greatest survival tool was each other. In Neolithic Vietnam, researchers found the remains of a young man they refer to as Man Back 9. He suffered from a congenital condition that left him completely paralyzed from the waist down, essentially a quadriplegic, for at least 10 years before his death around age 25. Now, in a society where everyone needed to contribute physically just to survive, his community actively chose to painstakingly nurse him, feed him, and bathe him daily for a decade. This proves that survival wasn't just survival of the fittest, it was survival of the most compassionate.
And this brilliantly illustrates that this kind of compassion goes back way further than the invention of agriculture. Consider the Sungher children burial site in Russia, which dates back an astonishing 30,000 years. A severely disabled young girl with a debilitating congenital condition was found buried there. But despite her physical limitations, she was not cast aside by her tribe. She was buried with thousands of ivory beads, and each one of those would have taken over an hour to carve by hand. This staggering investment of time and resources shows that her community deeply valued her, treating disabled members with profound respect and care. So, the whole idea that early humans just naturally expired of old age at 30, it's a complete statistical illusion. If they managed to survive the gauntlet of childhood infections, they lived long, active lives, supported by remarkable immunities, natural medicines, and deeply compassionate communities. Today, modern medicine has thankfully largely removed that early mortality filter, extending our life expectancy at birth dramatically. But it leaves us with a really provocative question. By outsmarting the ancient pathogens, have we simply traded early death for decades of managing the chronic, sedentary diseases of civilization?
It's definitely something to think about the next time you picture our robust, resilient ancestors.